Hi everyone, thank you for coming. Today we have our fourth Python meeting, and today Victoria Catán is going to show us how to use CIGALE. For the people that are watching the recording, we have everything in our webpage, so you can see everything that Victoria is going to present today. So thank you for coming, and today we have right in this
Victoria, everyone. So today we're gonna do a little overview of CIGALE. So CIGALE can be used for different things, but we're mainly gonna use it for SED data. So what is CIGALE? It is a Python code that is used to fit spectral energy distributions. And usually we use it to estimate physical properties of galaxies. So you have different models and templates that estimate different properties of the galaxy. And the main thing is that it's based on the energy balance principle. So everything absorbed in the dust, absorbed by the dust is emitted in the mid and far infrared. And it also uses a Bayesian-like approach. So basically it does maximum likelihood for everything to find the best read of parameters. So I'm not gonna show you how to install it, but here is the link that's gonna be there. Because it's a long process, you have to do an environment and different stuff. So you can do it with Conda. I use UV, that is another thing, but Conda is just fine. So you activate the environment and you can use it as well. So how it works? It has two modes. The PDF analysis mode, that is the one we're gonna be focusing on, that is used to fit the SEDs and estimate the properties. But there's also a safe fluxes mode, that is used to simulate models and other things. So I haven't used that one. I don't know why you would use that, but maybe it's useful for some people. So what's important, the data has to be in an ASCII file. So it has different columns. It has to be the source ID, then the redshift. It can be set to negative if you want to find the redshift. However, I don't recommend CIGALE to find redshifts. I think Lefebvre and Easy are better, and Backpage, I think, people also use, are better to find redshifts because this one mainly focuses on the parameters. And also you can add a distance column in case you're looking for like local universe things. So the fluxes have to be in millijanskis when you're doing photometry, but if you're putting an emission line, that I'm going to show you, that you can have either a band from a telescope or you can put an emission line. It has to be in watts per meter square. So also the filters name must be in the CIGALE database. So when you run this parameter, all the filters available are going to appear here. However, it could happen that you want to use a filter that's not available in CIGALE, so you have to add it yourself. And then you have to create another ASCII file with either energy or photon, with the wavelength and the transmission. So this website here is very useful for that because you can download it for a lot of different bands in different telescopes. So I'm going to show you. Sorry, that's not going to work. I need to share. So here, for example, I run, and in the right folder, I run CIGALE filters at that file. So this file, if you see it here, is an ASCII file that has the name I want to use, the photon, and then a comment. So that's a map and file, and the wavelength in angstroms and the transmission. So then I just run this command, and it's gonna add the filter. Takes it. So now I can use that filter to actually be one of my columns. So the data files, as I told you, have the ID, the redshift, and the different filters that have to be in the CIGALE form of writing them. We cannot put like in any form. So you put the data, the flux, and 1 sigma error. If you want to do an upper limit, then you put the error as negative. And that way it would be. However, I recommend using a little value because if not, you're going to have like a huge upper limit bar if you use like -1 and your fluxes are like 0.3. It's going to show very. So how do you actually run CIGALE? The first step is to run the CIGALE init. So we're going to go to the folder with our file. That is Python confi. And then I have the data file here. That actually I have to change the name because it's not coming. So as I told you, this one, it's gonna have all the filters. In this case, we're using HST. And the names, I just use number for the names because they're not very important. And then you run. You don't have to run UV run. You just put PCIGALE. And that's gonna create two files, the PCIGALE.ini and the PCIGALE.ini. This one you don't touch. This one we have to edit. So here you have to put the data file. So in this case, you put I have to put this one. Parameters file, you don't have to fill that. And here you want to put the SED modules you want to use. So for example, you want to use this transformation history or these simple state calculation forms and other things. So you just put them out here. And you have to put a redshifting also because it's mandatory. In analysis method, we put PDF analysis because we're using that method, and cores. Think of how many cores your computer has or the server you're using, and don't use all of them. I mean, because if I use 8, my computer, this one is very small, the data frame, but for example, I was running one that had a very large data set, and I used the 8 cores, and my computer just didn't work for like 40 minutes, so.
Victoria, I presume that you can in the command line you can pass this as variables and yes, optional parameters.
Some of them are optional, another not. So here, for example, so this one, and I already have one filled in.
So you can use different CIGALE.ini.
Yes. So for example, here I'm using these different models. So we're using as delayed star formation, Brussels and Charlotte, 0% correlation, nebular lines emissions, the dust model, that dust model, and this dust emission. So and the redshifting that is.
Yeah, no. I'm saying in the command line in the Linux terminal, can you provide different parameters?
No, you have to open the file and fill it. So now that I have all of that. And now we already have the file there. So the next step is to run PCIGALE.conf, sorry. And that's gonna read all your information and create an even more detailed file. So this is important now. So this file increase all of this. So now you have to give values for all these parameters. So for example, the age main, you have to, this one is the one I already have. This one. So you have to give values. It's important that you don't go over the age of the redshift. So if the galaxies are redshift 2, don't put an age of 13 gigayears. So that doesn't make any sense. I think it's not gonna work if you do, but still like think a little bit of which parameters. Also, if you're seeing a high redshift galaxy, maybe put a metallicity that makes sense and all those, or you can either, so this one is already filled. So for example, these galaxies are redshift, I think 1.9. And I added all the different parameters. Here, you also have the option of using these. So here it's like you use an arrange.
Are these like initial guess?
Yes, so what you're doing here is creating a grid. So you have a grid of all the possible parameters and it's gonna find the best ones. So for example, here, if I do this, it's gonna do all the values between 0 and 2 at a distance of 0.04. So that way you can add a lot more parameters. So different alphas, and so here you put the variables that you want to use. It is originally gonna have all the possible variables from your things, but just keep the ones you want. So in this case, we kept the star formation rate and the stellar mass, because I'm not interested in the posteriors of the other things. Save this SED, you have to put it as true, and save chi-squared as properties. And that's all you have to do. So now I'm going to go to the other file. So afterwards, you can do the CIGALE. Sorry, I forget I have to do the UV. Right? The CIGALE check. And this is going to show you if there's any problems in your data. So here it says no critical errors has been found. So you just put CIGALE run, and it's going to start running. It has a nice interface. Yeah, you can say Steven.
If I have a question, or I don't know, can CIGALE be used for another type of CD you want to take, for example, a nebular emission, or like not necessarily a galaxy or a stellar population?
No, it's for galaxies. CIGALE it's used for galaxies. So all the templates it has is for galaxies. So there it's gonna run. So I'm gonna go back to the presentation now. And we saw that the first step is CIGALE. So the output folder, hello, it's gonna have results.fit file that's gonna have all the parameters you obtain from your SED fitting. And it's also gonna have the object best model .fits. That's gonna be the fits. But then you can obtain the PDF images of the posteriors by running different things. So I'm just gonna wait till this runs. Sorry, I thought it was gonna be short there.
Don't worry.
Maybe I took some little course. So yeah, I don't know if there's any questions, meanwhile.
I just have a question of what you said before. Are you going to show for the emission line also configuration?
No, I personally I don't use emission lines to fit together. So because usually I take one point of the photometry, so you mainly use like the photometry in a band. But for example, if you have an emission line, you can obtain the equivalent width and give that to the here. So let me just I'm gonna open another terminal. So
it's not fitting right now, it's just computing the models.
yes, it is computing the models, and once it computes the models, it's gonna find the best fit. So let me just go to CIGALE. So if I put UV run CIGALE filters list. Here it shows me all the things, and it includes also the emission lines. So here it has the rest frame frequency for the line, and you just add the line and the emission, the equivalent width in the units. I told you that were watts per meters.
Okay, and you can mix the emission lines with the other formats.
That's like my
No, see, it has a lot of lines, and then different telescopes, the different things. What happened? Oh, sorry, I don't know what happened, but I'm just gonna go to another folder too. So basically, so this one, it's gonna create an out file, and it's gonna create the posteriors for the different things. So here we have the observations, that's gonna be the observed data file, and we're also gonna have the results.fits. And that's the one you're interested in. It's gonna be, it have txt and also fits file. So let me just, we're gonna go here. So what you run then is the UV, just the parameters here. So CIGALE plots SED, no logo. You can not put this, but it's gonna show the CIGALE logo here and it looks very ugly. And then the CIGALE plots PDF, and it's gonna create all the posteriors you asked for. So for example here, let me just go to the PDFs. This galaxy, this is the saturation, it doesn't have, that's the best fit for the SED. So that's another galaxies. I don't know why it didn't work the other one, but you can see that the observed fluxes are the purple ones, the model are the red ones, and then you have different contributions to the SED fitting. So now if you go to the results file, you're gonna see the different parameters, and here you can have the stellar mass, the star formation rate, and everything you asked it for. So
And then you like extract the model spectrum that CIGALE gives you?
yes, you can have the SED. So the best SED is gonna be in a fits file. So it's gonna be called bestmodel.fits. I can open it here,
But
but
it's like a aspect.
yeah, it's gonna have the y-axis and the x-axis of the SED fitting, and it's only gonna have the best fit and the points.
At the observatory, yes.
The observations, no,
No, at the redshift of the.
at the red, yeah.
Best model is like as you observe it or like best friend?
No, as you observe it.
Yeah, I see. Because you can fit like this.
So I don't know if it's wait, just-
So when you do this, of course, you may have like a small number of galaxies to show, but what if maybe I want to do it for a large data frame? Can I just save the last PDF with everything else, yes, or do you have to save each individual like that fits for each galaxy?
No, you in the ASCII file, you can put as many objects as you want.
Okay.
So same filters, and for example, if you have two galaxies, one they share the same filters, but one has 5 and the other has 7, you have to put a none in the.
Okay.
So the none here would be like minus 99, for example. You use that and it takes it as a none.
But then if you save it, it's gonna save every single like.
It's gonna save the every galaxy.
Okay.
No, so you only have to run it once. If you use a lot of galaxies, it will take a long time. So if you have a server available, I recommend that you use a server, special and screen, because if you leave it in screen, it will run as long as it needs, and you don't have to be there to see.
That was it. Thank you.
Any more questions?
Is the fitting like completely like automatic, or you can control like intermediate steps?
No, it's automatic.
So you run it.
I mean, what you control are the possible initial parameters, so the read you give it. So, for example, if you want to see, I don't know, if you think your galaxy has a metallicity of a certain value, you give it that value also. Or if you already know the metallicity, you can give that fixed metallicity. You don't have to put a grid of parameters.
Yeah, I do have a question before you do. The spectrum you show is actually go to the far infrared, the medium.
The
Are
one,
you constrain it, just to the optical or?
I mean, with the wavelengths you give them, it's gonna give you
Okay.
that wavelength. So, for
you-
example, this data here, that was the best model. This is near spec data. Sorry, not near spec, near gap data. So that's why it's so infrared. But if you put observational bands like HST, it's gonna have more optical.
Mhm.
And for example, let me see if I can show you. So, no, I don't have it. But for example, you can have the optical data and also the an ALMA bandlab, for example. So for my galaxies, I have data in HST, in JWST, and also at ALMA data point. So it covers a long range of spectrum.
Okay, so again, thank you for coming, and also thank you for everyone who's watching the video. If you are watching YouTube, please subscribe to our channel. I will take more videos on astronomy. So thank you for coming, everyone, and see you next week.
If you're online and you have questions, you can find me and ask me the questions. Also.
Hit that like button.
Yes. Like and subscribe.
Hit that button.